Okay guys, so I'm not going to be there tomorrow and for Friday, so this is going to be Friday's lesson. I'm just going to give you a basic hash of trig ratios. So we're going to look at trigonometric ratios. Now trigonometric ratios is the beginning of trig, and it all has to do with the ratios of the sides in a right triangle. I apologize, you're going to hear puppy dog pals in the background because I've got my son with me. So let's go ahead and start looking at these functions. Now, again, trig ratios are all founded on the ratios that we use in right triangles, okay? So what we look at are three different types of functions, and the first one is called sine, okay? That's how it's pronounced. Now, we don't write it out. If you look at your calculator, you don't see S-I-N-E, you see S-I-N. So we write it like this. And then we follow it with the angle. So what I'm going to do is we're going to look at angle A first. So we're going to look at the sine of A. Now there is a space here. It's S-I-N space angle. This is called your angle, okay? The sine is this ratio. It's the side opposite the angle over the hypotenuse of the triangle. So I'm looking at the side opposite angle A over the hypotenuse. So if this is angle A, this side would be the side opposite, correct? Because it's across from the angle. This is the hypotenuse because it is the longest side and it's across from the right angle. So for sine, all we do, if our lengths are 5, 12, and 13, for me, the sine of A is going to be opposite, which is 12, over hypotenuse, which is 13. So we have 12 over 13, and that's it. So the sine of A is 12 over 13. The ratio of the side opposite A to the hypotenuse of the triangle is 12 over 13. Now, let's look at the next function. The next function I'm going to do is I'm going to do cosine. Okay? Cosine is like this. And again, if you look on the calculator, it's pronounced cosine, but we abbreviate it a bit, so it's going to look like cos. So we'll look at cosine. The cosine ratio is the side, what we call adjacent to the angle over the hypotenuse. So for angle A, this is the adjacent side because it's right next to the angle. This is the hypotenuse. So the cosine of A is 5 over 13. All that these trig functions are is ratios. They're all ratios, okay? So let's look at the last one. The last one that we have is we have tangent. Okay, so I'm going to slide this up a little bit. We have tangent. Tangent is the last function that we're going to deal with. And we just use 3 letters, so it's going to be tan. So I'm going to have tan of angle A. And tangent is the opposite over the adjacent. The tangent is the only one that has nothing to do with the hypotenuse. So which side is opposite A? The 12. So tangent of A equals 12, which is the opposite side, over 5, which is the adjacent side. And that's your 3 ratios for the triangle. Now, I'm going to come over here and I'm going to go in different color. And let's look at now what happens if I were to choose angle B instead. So instead of doing sine of A, I'm going to do sine of B. Now, according to sine is the side opposite the angle you're looking at over the hypotenuse. So what's the length of the side opposite B? Now, this becomes your opposite side. Does everybody see that? So now, what's opposite from B? 5. And the hypotenuse is still what? 13. So you can see the sine of A is a different ratio than the sine of B. The sine of A is what side is opposite the A over the hypotenuse of the triangle. The sine of B is what side is opposite B over the hypotenuse of the triangle. So let's look at cosine. We'll do the cosine of B. Well, now that we're doing B, this side becomes the adjacent side. This is now right next to angle B. And remember, cosine is adjacent over hypotenuse. So the cosine is going to be 12 over 13. 12 over 13. So let's do the last one. Let's do tangent of B. So tangent is the side opposite the angle over the side adjacent. Well, if I'm looking at B, now opposite is the 5, and adjacent to B is the 12. So the tangent is 5 over 12. Okay, so I want you to look at these operations here. All you're doing is looking at the angle and determining the ratio of the lengths of the sides based on the location they are compared to that angle. So it's opposite, adjacent, and hypotenuse. Well, in a right triangle, the same side will always be the hypotenuse. So every time you see the word hypotenuse, it is always going to be the same length, because in a triangle, the hypotenuse is always the hypotenuse in a right triangle. For the adjacent and opposite sides, it just depends on which angle you're looking at. If I'm looking at angle A, I have opposite here and adjacent here next to it. If I'm looking at angle B, I have opposite here and adjacent next to it. So look at the sine of A and look at the cosine of B. Do you notice how they're the same? Sine of A, cosine B. Because what happens? What was opposite becomes adjacent, and what was adjacent becomes opposite. That's why these are the same. Look at the cosine of A and the sine of B. When you flip angles, the opposite and adjacent switch. And then look at tangent. Tangent, 12 over 5, 5 over 12. The tangent becomes the reciprocal when you flip angles, because adjacent over opposite becomes opposite over adjacent as far as number-wise when you change angles, because what was opposite becomes adjacent. So you've got to look at perspective based on where you are in the triangles, okay? Now there's a way we can remember the functions, and it's called SohCahToa. SohCahToa. Now, what does this stand for? Well, it tells you sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you can remember SohCahToa, that will help you remember which function has which relationship. Again, sine opposite over hypotenuse. So I've got SoH, sine opposite over hypotenuse. And then if I go back and look at cosine, I have cosine is the adjacent over the hypotenuse. So here we are down here. Cosine is adjacent over hypotenuse. And then we've got tangent, which is opposite over adjacent, which is the toa part. So SohCahToa, that's how you can remember it. So let's do one more set of examples here. I'm not going to be able to keep the whole thing in the frame. So let's look at one last set here. I'm going to draw us a couple of triangles just to give you some examples. And we'll make this triangle PQR. And I'll make this a 3, 4, 5. Okay. And then I'll make this triangle here AKC. And we'll make this a 7, 24, 25. Notice what I'm doing. I'm using some of the Pythagorean triples. So let's remember what we just learned. SohCahToa. Sine is opposite over hypotenuse. And I'll put x there because we don't know what the angle is. Sine of x. Cosine of x is adjacent over hypotenuse. And tangent Yeah. So tangent of x, that's my son, is opposite over adjacent. So let's look at these. We'll do the first triangle. What's the sine of P? The sine of P is, sine is opposite over hypotenuse. What's opposite of P? 3. And what's the hypotenuse? 5. That's it, you're done. What's the sine of Q? Well, if I go sine of Q, now opposite over hypotenuse. What's opposite Q? 4. And what's the hypotenuse? 5. So I've just done the sine of P and the sine of Q. So let's look at this triangle with cosine. All right, let's do the cosine of P. Cosine is adjacent over hypotenuse. Which side is adjacent to P? The 4. And what's the hypotenuse? 5. So cosine of P is 4 over 5. And let's do the cosine of Q. Which side is adjacent to Q? The 3. And what's a hypotenuse? 5. 3 over 5. So you've just done the cosines of P and Q. Again, it's just a ratio of sides. Don't make it more complicated than it looks. All right, the last one here, we'll do the tangent of P. And for P, what's opposite? Because tangent's opposite over adjacent. 3. Adjacent is 4. So the tangent of P is 3 over 4. And the tangent of Q, here we go, puppy dog pals again. What's opposite Q? 4. And what's adjacent to Q? 3. Remember, the tangents will always be reciprocals of each other, and the cosines and the sines will flip. So what was sine of P will be cosine of Q, etc. So let's look at the second one. Let's look at our second triangle here, and I'll try to fit this on the side here. Let's go sine. So if I'm looking at, let's do the sine of A. Sine is opposite over hypotenuse. What's opposite of A? 24. What's the hypotenuse? 25. Okay? So let's look at the sine of C. Now, what's opposite of, sorry, not the sine of C, the sine of K, because we won't do the right angle. What's the opposite of K? 7. And what's the hypotenuse? 25. So you've taken care of the two sine ratios. Now let's do cosine. I'll do cosine of A. Cosine is adjacent over hypotenuse. So for A, which leg is adjacent? 7. And what's the hypotenuse? 25. So 7 over 25. Now let's do the cosine of K. What's adjacent to K? Which leg is next to K? 24 is next to K. Hypotenuse is 25. Okay, so that takes care of the cosines. Remember, the sines and cosines flip, so what was sine of A becomes cosine of K. The last one is tangent. So we'll do tangent of A. Tangent is opposite A over adjacent, so 24 over 7 would be the tangent of A. And the tangent of K, now opposite of K is 7, and adjacent is 24. So you can see that they flip. So that is how you do trig ratios using right triangles. It's just a relationship between the sides. But remember, SohCahToa, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. The hypotenuse is always the hypotenuse. Your adjacent and your opposite are your two legs. So in this triangle, adjacent and opposite will always be either 4 or 3. The 5 is always the hypotenuse, nothing else. The 25 is only the hypotenuse, nothing else. Okay? So that is trig.